G'day Year 11s again. Hopefully this would be a Tuesday that you're watching this, or maybe Monday night. Well, I'm still doing it on a Sunday. Okay, let's do this. I've got another 2 videos to make for you guys, and another probably 2 or 3 for my Year 12s. But let's see what I can do for you before the end of the day. So, that's just introduction, exercise 2D. So let's recap what you've learned so far. You're meant to have learned exercise 2A, distance, and midpoint formula. Okay. Exercise 2B, you learnt about gradients. How many types of gradients there are. You have a positive gradient, which looks like this, a negative gradient, a zero gradient, which is a horizontal line, and an undefined gradient. And then, you know, how to find gradients like y2 minus y1 over x2 minus x1. That's your exercise 2b. And then 2c, you had your y equals mx plus c, which I made just an hour ago, which hopefully you watched either Sunday or Monday. Okay. And you had to work with finding m or c or both. Given 2 coordinates or 1 coordinate, that's what you were doing in 2C. So today, now that you can get the equation for a straight line, the question is, can you draw it the way I was drawing it before? You know, in exercise 2C, I quickly drew a graph so you can see. Yeah, and that's what I'm going to do today. I'm going to try to show you how to sketch the graph of a straight line. Okay, and back in year 9, there were 2 methods. There was the gradient y-axis method, and then you've got X-Intercept and Y-Intercept method. Yeah, I like this method more just because it works with your algebra, and you get your head around what an X-Intercept and Y-Intercept is. You know, like when I taught you, I said y equals mx plus c, and I said this is the Y-Intercept, and I told you guys that I don't like you guys memorizing it. I'm gonna explain why we say C is the Y-Intercept. Okay, some of you may have already picked it up, but you know, I'll describe what it is. Okay, so let's do the first example. Let's have a look. It says sketch the graph of 2x plus 4y equals 10. Now I know I usually say rearrange the equations so that you can get mx plus c. Yeah. I will do that now, and then I will show you that you don't actually need to do that. I'd just like to do that so you can get in the habit of knowing that you always need to go back to y equals mx plus c. Okay, so let's have a look at this equation here. I've got 2x plus 4y equals 10. So hopefully by now you can rearrange the equations because it was from exercise 2b. So here, what I see is it's a positive 2x, so I'm going to say minus 2x on both sides because it's the opposite of positive. 2x minus 2x is 0. So now I have 4y equals to 10 minus 2x. Almost there. And I don't want 4y, I want y. Now because this is 4 times y, the opposite of that is divide. So I'm going to divide both sides by 4. 4 divided by 4 cancels out to be 1. And now I have 1y, which we don't write 1y, we write y. Okay, so it cancels out to be 1 here. 1 divided by 1 is 1. And because that cancels out, it's 1 times y, which is y. Yeah. Now you got 10 minus 2x on 4. I know a lot of students don't like fractions, but you know, you're going to have to work with this. You can split this fraction up into 10 over 4 because the denominator is the same. So you can write it like this. Okay, back to grade 3 and 4 maths. Splitting fractions, yeah? So now I've got 2 fractions there. I can simplify that. 10 on 4 can be simplified down to 5 on 2, because I can divide 2 into 10 and 2 into 4, yeah? Minus, again, 2 on 4 is the same thing as saying half. So it's 1x on 2. But we don't normally write 1x, so we write y equals to 5 on 2 minus x on 2, okay? And some students don't like this because they can't tell which one's the gradient, what's the y-intercept and whatnot. Another way of looking at this is 5 on 2. Don't write as decimals. Don't ever write in decimals. Yeah, I know how often students love decimals because it makes more sense. They hate fractions. Keep it in fractions. Yeah. Minus. Now, I said this was half x or x on 2. So you can just write it as half x. That's fine. There's nothing wrong with that. Because this basically means half times x. and half times x is this. Whoops. That. Okay, it's that. Half times x. See, x is the numerator. Is like saying half times x on 1, and x times 1 is x, and 2 times. That's why it's the same thing. Yeah? So you can write this as half x, is what I'm saying. Okay? Alright. So, now I've written as half x. So here, we can already see what are you multiplying to x? Negative half. That's my m. M equals negative half. C, which is 5 on 2. Okay? That's just like what you did in exercise 2C. It's just now you got fractions in it. Yeah? Now, what I want to say is you didn't have to go through all that just to get y equals mx plus c to sketch the graph. You don't need to. I'm just doing it so you learn the algebra, especially if you're not so strong with your algebra yet. Okay, so I'm just showing you the steps. Learn it. Take your time. There's no point trying to avoid it now because it'll catch on to you. A good analogy would be like gymming. Yeah, if you just work your biceps and chest, you might get large pecs and big biceps, but if you neglect your legs, eventually you'll see the difference, and it'll catch up onto you and never have a great overall physique. Now, it'll be the same with mathematics. If you don't train your algebra and your fractions, eventually it will catch up to you, and it's not going to look good for you on your results. Okay, so here we go. How to sketch. To sketch, I'm going to show you or remind you of the X-Intercept and the Y-Intercept method. Basically, in order to sketch a straight line, you only need 2 points. Literally, just 2 points. That's all you need, right? Because if I got 1 point, well, how am I going to draw the line? You know, I can draw it like this, but you can't be accurate. You don't know where the other one is. If you have 2 points, doesn't matter who, everyone will draw the same line because they cross the same 2 points. Yeah, you're not going to draw this because it doesn't cross the second point. That's why the only 2 points you only need 2 points to draw a straight line. And in our case, we want to find the X-intercept and Y-intercept. Okay. Now I know I said the Y-intercept is always C. What I don't like is that students memorizing that. Okay, there's no point memorizing. It's trying to understand it. So right now, if you think about it, you got y equals to mx plus c. Y is c, the y-intercept. Why is that? Okay, let's have a think. Why is that the y-intercept? Now, y-intercept means a point that you have on the y-axis. True? So it could be 0, 3, for example. Okay, you can have 0, 3. Now, if I gave you an equation, let's say y equals to 2x plus 3. Now, what you would tell me is you'd say the gradient is 2, and you'd say that the y-intercept is 3. So naturally, you'd say, yes, that's where it crosses, right? But why? Why do we say that this number 3 here is the y-axis intercept? Now, the y-axis intercept is basically when you have a point on the y-axis. Now, funny enough, any point on the y-axis, okay, any point on the y-axis, let's say if this was -1, you would say that the coordinates is 0, -1. If it was over here and that was 10, you would say that is 0, 10. That's the coordinates at that point. So any coordinate on the y-axis or the y-axis intercept, any coordinates there, we know one thing. The x-coordinate is always 0. X is always 0. See, x is always 0. So because x is always 0, well then in my equation here, when I said y equals 2x plus 3, well then, if x is always 0, then let's say, well, when 2 times 0 plus 3, whatever this y equals 2, that should be my y-intercept. True? Because if you put in x equals 0, what you're meant to get is y equals 3. That's your y-intercept. So in my case here, I can see that y will equal to 2 times 0, which is 0, plus 3, and that gives me 3. That's why we say this is your y-intercept when x is 0. So when x is 0, we found out that y is 3. Okay? That's the reasoning. The reasoning is because if you substitute 0 here, it's always going to cancel out, and that will be your y-intercept. So the question is, well, why do you have to substitute 0? Because on the y-axis, x is always 0. Now, funny enough, if you want to find the X-intercept, X-intercept means a point or a coordinate on the x-axis. Now we know that on the x-axis, this would have been, let's say if that was -1, it would be -1, 0. -2, 0. Could be 5, 0. And what we know here is all the y coordinates are 0. So if you want to find the x-intercept, you know that y has to be 0, and it would just be the other way around. You have to solve when y is 0. Okay, so that's the gist of what I'm trying to say here. So let's go and have a look. Well, there's a lot to rub off here. But let's have a look on how to sketch this line. Actually, I'm going to rub everything off, okay? So if you want to see all of this, just go backwards, yeah, on the video. I'm going to cancel all this out. All right, here we go. Start from the beginning. So sketch the graph of 2x plus 4y. So what I was saying is, in order to find the y-axis intercept, we know that x is always 0. That's what we know. Every coordinate on the y-axis, x is always 0. We don't know what y is, but we know x is always going to be 0. It doesn't matter where. As long as on the y-axis, x is always 0. So if that's true, so this equation here, 2x plus 4y equals 10, I know that x has to be 0. So that's what I'm going to do. I'm going to say, all right, well, if x has to be 0, well then what I have now is I've got 2 times 0 plus 4 times y equals to 10. 2 times 0, which is 0, plus 4y equals 10, and 0 plus 4y is 4y. Okay? And now what we want to do is we want to solve for y. And again, we don't want 4y. So to remove this 4, this is 4 times y. The opposite of times, divide. So that's what I'm going to do. I'm going to say divide both sides by 4. I'm keeping the equation balanced. If I take it away from my left pocket, I take it away from my right pocket. Yeah? So here we go. 4 divided by 4 cancels out to be 1. 4 divided by 4 is 1, not 0. Okay? 4 share 4. If I had $4 and I'm sharing it between 4 friends, they all get $1. Yes, I now got 1y. So 1y, which we normally don't write the 1. Okay, so it's got y is equal to 10 on 4. But we don't write 10 on 4. We simplify that. That's 5 on 2. And remember in the last example, when I did before I wiped this entire screen, I showed you that when I rearranged it, we saw a 5 on 2 before. Go back to the video again. You'll see that my C value is 5 on 2. So what does this mean? I've just figured out when x is 0, my y-axis intercept is 5 on 2, which is 2.5. So what that means is on my y-axis right now, at 5 on 2, which is 2.5, so 1, 2, 5 on 2, and this is 3. 5 on 2 should be around here. This is where my y-axis intercept is. So I got 1 point. Remember, you only need 2 points to sketch a straight line. So I already got 1 point. Now I just need one more, which is now the x-axis intercept. Whoops, axis intercept. Now, same thing, x-axis intercept just means I'm going to have a point on the x-axis. So if this is my x-axis, any point on the x-axis, I know the y-coordinate is 0. I just don't know what x is. So if I know the y-coordinate has to be 0, well then in this equation, 2x plus 4y equals 10. I know that the y-coordinate, so remember I just said, the y-coordinate, we know that it's going to be 0. Y has to equal to 0 for it to be on the x-axis. So if that's true, then my equation now becomes 2x plus 4 times 0 is equal to 10. That now gives me 2x plus 0 is equal to 10. That now gives me 2x equals 10. And we don't want 2 times x equals 10. We want x. So the only way to get x, again, if this is 2x, which means times, the opposite of times 2, which is, yes, divide 2. Whatever you do to one side, you do to the other side. Divide both sides by 2, and you can see 2 divided by 2 is 1. Not 0, 1. Okay, so now you have 1 times x, and that gives you 1x, but we don't write the 1, equals 10 divided by 2 is 5. And so what does that mean? After doing all of this, what does it mean? It just means I found the x-intercept is, I know y is 0, I just didn't know what x was. Now I just figured out x is 5. So now I've got my coordinate, 5, 0. So 5, 0 must be somewhere over here, for example. So it's 5, 0. Now I've got 2 points. We can all sketch a straight line if we have 2 coordinates. There you go. This is my equation, y equals 2x. Whoops, no. This is my equation, 2x plus 4y equals 10. Okay? So all I did, I'll just remind you what I just did. So all I did was I said, when x is 0, find y. That's to find the y-axis intercept, because x is always 0. Whereas the x-axis intercept, I know that the y-coordinate is always 0. So I sub 0 in. So y, I subbed it in, and I just tried to solve for x. Once I got the 2 coordinates where y equals 5 and 2 and x equals 5, I joined the 2 coordinates, and that gives me the picture of my straight line. Okay? I'm going to use this method consistently throughout the PowerPoints, but that's all you have to do. You can see there's a lot of algebra, that's why I don't want you to skip out on it, and don't use decimals, work with fractions. Notice how I labeled my graphs as well. I didn't skip out on anything. I had y-axis intercept, I had my x-axis intercept, I labeled my axes, I labeled my equation. Yeah, I meant to use a ruler, but I'm doing this on a tablet, I don't have a ruler. Okay, so that's how I want you to sketch it as well. So what I've done here, I want to see that in your exercise book. Okay, don't skip out on steps. I don't want you to skip out on steps. How I laid it out, see how I keep everything vertical? Equals, 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 equals. I want you to do the same. Get in the habit of getting your layout correct. Okay, year 11 and 12, your technique is very important. It's so important in order to not make a mistake, and 2, for examiners to read your thinking and your process. Get in the habit of laying out your information, write it correctly. Okay, I'm going to do the next one, and this time with less explanation. I'm just going to go through how to find it using the axis intercept. Okay, same thing. Here we go. Sketch the graph of y equals 2x minus 6. Now they've changed this equation to 2x minus 6. So this is perfect because from it, you already know what the y-intercept is. So you can tell that the y-intercept is negative 6. That's your c value. C equals negative 6. But let's say you didn't know that. We're going to still go through the same process I showed you before. Y-axis intercept. We know to find this, we know that the x-coordinate is always 0. We don't know what y is, but we do know x is always 0. Okay, that's what we know. So according to the equation, y equals 2 times x minus 6. We know that x is always 0, so now you have y equals to 2 times 0 minus 6. It's always 0 at the y-axis intercept, yeah? And now that gives me y equals 0 minus 6, and that gives me y equals to negative 6, just like what I said before. That's what we've been learning. This is your c value. That's why we know y is negative 6. So now I know I've got a coordinate at 0, negative 6. That's where my y-axis intercept is. Okay? So 0, negative 6, maybe around here. That's 0, negative 6. There we go. I got my first point. I just need a second point to find out, to sketch the graph. Yeah? So x-axis intercept. We know that for the x-axis intercept means where the point lies on the x-axis. We know when it lies on the x-axis, the y-coordinate has to be 0. Okay, the y-coordinate is 0 because this is 1, that is 2, that is 3. Then obviously this line here, that's y is 0. So we know that y-coordinate has to be 0. So according to this equation, y equals 2x minus 6. If we know that y is always 0, then now I have 0. That's my y-coordinate. 2 times x minus 6. Your job now is to use algebra to solve for x minus 6. So I add 6 on both sides. Negative 6 plus 6 cancels out. So now I have 0 plus 6, which is 6, and 2 times x left over. I don't want 2 times x, I want x. So this is times, so the opposite of times is divide. 2 divided by 2 is 1. So now I have 1x is equal to 6 divided by 2, 3. What does that mean? It just means I found out when x is 3, the y-coordinate is 0. Or when the y-coordinate is 0, x has to be 3. So if I were to plot this coordinate 3, 0, okay, where's 3, 0? 3, 0 will be about, say here, 3, 0 on the x-axis. This is the, whoops, this is the y-axis. Okay, using a ruler. I don't have a ruler, so imagine that was nicely drawn. There's my straight line, and label your equation y equals 2x minus 6. That's how I want to see it in your exercise books. See, I labeled my few things. I labeled my x-intercept, y-intercept, labeled my axes, labeled my equation. Yeah? That's what I expect when I do the SACs and test. That's what I want to see, how you're laying out your answers as well. Okay? If I check your exercise books when I walk around class and I see that you're skipping steps, I'm going to cross it off. Yeah? Poor layout leads to poor results. Trust me on that one. Okay? Alright, next one. Let's go to these ones here. So, same thing for each of the following lines. Find the magnitude of the angle corrected 2 decimal places that the line makes with a positive direction. So this is exercise 2B. If you remember 2B, the last thing we left off, which was the hardest one to get your head around, was tan of an angle. So that's where I left off. I said M is equal to tan of an angle because tan of theta from year 10 is opposite over adjacent. Okay, that's what your gradient is, and you can see that this is theta, this is your opposite over adjacent, but at the same time, this is your rise over run. Okay, so that was from exercise 2B. Go back to it if you've forgotten it. But opposite, yeah, so that's why we know we're going to use this now to try to find the magnitude of the angle. That's what we're trying to find. Okay, so let's start with the first one. First one, A, y equals to 2x plus 3. Now what we know is this is the gradient, m equals 2. But at the same time, from what I just taught you just now, or just revised with you, m also equals to tan of theta. So that means these two must be the same. If 2 is m and m is tan theta, then therefore tan theta must also be 2. Agreed? Yeah, m is 2 and m is tan theta, so m could be either. So that means 2 is the same as tan of theta, or tan theta is the same as 2. And your goal right now is to find tan of theta. Okay? If you roughly sort of picture what this graph is, the y-intercept is at 3, so it looks like this 3 and a gradient of 2, so it's positive, so it looks something like this. Your job now is to find out the magnitude, the angle that it makes with the positive direction of the x-axis. In positive direction, this is the positive direction with the line, that's the angle that it makes. Yeah, that's why I've drawn it here. That's the angle that it makes, theta. That's what you're trying to find. So how to find that? You can use rise over run, so adjacent over, opposite over adjacent. Yeah, tan of theta. So here, that's what I wrote. Tan of theta equals 2, because we already know the gradient is 2. The steepness is 2. So theta, if you want to find out theta on your calculator, to remove the tan, you got to do the inverse, which is tan inverse and tan inverse. Okay, tan inverse of tan will cancel out, and you're left with just theta. And now on the right-hand side, you just need to type in your calculator what tan inverse of 2 is. Okay, I'm gonna quickly do that on my calculator. I think I have a CAS calculator here. I'm gonna just open this up so you can see. Wait, that's not right. This is, where is it? CAS. There we go. What is the answer? Come on. It's gonna take a while. Probably should get a drink after this as well. I'm talking on for a whole hour to myself. Oh, here we go. So menu, I'm gonna go to calculator. So menu 1, calculator. And I wanna do tan inverse, so trig tan inverse of 2. I just gotta check that my mode is in degrees. No, it's in radians, so degrees. There we go. Oh, that's bad. Ignore that. Just do it again. If you had the same problem, just hold on to Control and press Enter, and you'll get your approximate answer. So I've got now 63.4349 degrees. Now, does it say round it off? Find the magnitude. Correct to 2 decimal places. Okay, so 2 decimal places, 63.43 becomes 63.43. Okay, so this is now 63.43 degrees. Okay, so that means this here, this angle here that it makes is 63 degrees, 0.43, sorry, 0.43 degrees. 63.43 degrees, 63.43 degrees. There you go. Okay, and that's part A. Now, the only times it gets tricky is when you're dealing with negative gradients. Okay, negative gradients is the trickier one because when you look at the gradients, rise and run, you only get this angle. But that's not with the x-axis, you see. So with the x-axis, it's over here. So the only way to get that angle there is if you got 180 minus whatever the angle you got from tan theta, and the leftover is the angle you want. Okay, I'll find one with a negative gradient, and I'll show you what I mean. Let's have a look at which one has a negative gradient. This doesn't have a negative gradient. They'll be the same thing as A. This one has a negative gradient. So C, let's have a look at C. I'll show you C. Whoops, what did I do? There we go. C, let's have a look at C. So C, for example, I don't like decimals because it doesn't teach you the algebra and fractions, but all right, we'll stick with this. Negative 0.3 x plus 1.5, okay? Now, that has a y-intercept, so again, C is 1.5, so y-intercept, let's say here's 1.5, so 0, 1.5. It's got a negative gradient, so I know the graph looks something like that. Like that. Okay. Actually, it's a 0.3, so it's a very flat. It's a very much more flat gradient. So let's say something. Actually, I'll just do it like this. Okay. Now, your job is to find the angle that it makes with the positive direction of the x-axis. Okay, so because it says positive direction of the x-axis, this is the positive direction. That's the direction. So the angle that it makes is this one. That's what you're trying to find. Okay, but when you do your rise over run is only going to work out. This is your run and this is your rise. See, that's your rise. You're only going to work out this angle, which through alternate angles, I know it's the same as this angle here. Okay, so just in case you've forgotten about alternate angles, see, this is your line. This is the angle that I was talking about just now, and I said that it's equal to this angle. Remember that? Parallel lines back in year 7 and 8. These two are equal. So if this is 30 degrees, this is also 30 degrees. Alternate angles, yeah? Our job is we want to find out this one, which technically it's co-interior. So 180 minus 30 will tell me this is 150. Okay? So, anyways, going back to my own problem, I need to find an angle first. I need to find what that angle is in red. Okay, so that's what I want to find out. And how do you do that? Same thing again. This is my gradient. This is my current gradient. Gradient is negative 0.3. Okay, but again, same thing. We know that gradient is also equal to tan theta, which means that tan of theta has to equal to negative 0.3. Okay. And because you know the gradient is negative, same thing again, we're going to now say to find out theta, theta will be tan inverse both sides. Notice how I'm laying out my answers. See, I'm writing tan inverse bracket negative 0.3. I didn't write tan inverse negative 0.3. Don't do that. Okay, that's just poor layout. Start using the brackets. Do it properly. Yeah? Here we go. So we got tan inverse of negative 0.3. We need to know what the angle of this is. So we're going to do again tan inverse. I just went up here and brought down that point. So negative 0.3. Okay. Now, what you can see is this tells you it's negative 16.69 degrees. So the question is, how do you have a negative angle? And what I want you to see is what you've just figured out right now is this. So this is a negative angle because it's below the x-axis. Yeah, anytime you go clockwise rather than anti-clockwise, it's a negative angle. So what we just figured out just now is this is negative 16. What was it again? It was negative 16.69, round to 2 decimal places, 16.7 degrees. Okay, so that's 16.7 degrees, but the problem is that's not our answer. See, the answer we want is this entire thing here. Okay, so now that I know, if this is negative 16.7, then this angle here, they're both the same. These two, this is also 16.7. The only difference is this is negative and this is positive. Okay, So I know that the magnitude of this angle here is 16.7. The only way to find out this angle here, like I said before, is if you took 180 degrees minus that angle. Okay? Because we know that in a semicircle, it's 180 degrees. If you already know parts of it, if you knew that this was 16.7, then obviously you can find out this leftover. It's like saying if I told you from here to here is 10, right? And then I told you that from here to here is 3. So then what's the leftover? This has to be 7. 7 plus 3 gives you 10. True? So the only way to know that is you did 10 take away 3, you get 7. Now, it's the same thing with this one. If you know the entire half a circle is 180 degrees, 7, and you know that this is 16.7, then 180 take away 16.7 will tell you the leftover side. Okay? So that's what I was doing here. Okay? So that's where it gets tricky. When you have a negative gradient, you just have to make sure you know you are taking the magnitude. Magnitude means the value. Don't worry about the sign. So tan inverse of this, we had 16.699. I'm going to keep it as it is. And then we know that the only way to get the proper answer is that theta equals the 180 minus that. Sorry, sometimes my mouse just sort of moves it up and down, so you might get this seizure effect. Okay, so to answer the question, 180 minus 16.699 would be my actual angle, which makes more sense. If you look at this, this clearly looks beyond 90 degrees. It's an obtuse angle, right? So if we roughly do this at 10, oops, no. It was 180 degrees minus, oh, but we don't want the negative. It's not a negative. Okay. We want the magnitude. So it's 163.3. So that makes more sense. 163.30 degrees. Okay. Another thing to note for the test later on in year 12 or your SACs, you never round your answer while you're calculating. What I mean is, you see how I kept 0.6999? I could have wrote that as 0.7. But if you do that, and then whatever your final answer is, you round it again, that's bad because you lose a decimal point or 2. Okay, so when they say correct to 2 decimal places, you only do that at the very end. So kind of like what I'm doing now. I took the entire decimal. See, it's 0.69924423394. I did 180, take away that. Full answer. Now I round this off. This is 163.301. I round that off to 2 decimal places. Okay, don't do it midway. Because if you imagine if there were like 4 steps in a question to solve it, and you kept rounding it to 2 decimal places each time, you're going to change the answer dramatically. You know what I mean? Okay, so that's why here you write your answer now 163.30 degrees. You don't have to put the 0. I'm just putting it in because it says 2 decimal places. Yeah. But that's what's tricky about the negative, like when you have a negative gradient. Just pay attention to that one. Okay. Let's see. Oh, and then you got your 2D. So we're done. I'm just gonna quickly browse through the questions, see if there's anything that I haven't taught you guys. Magnitude. So yeah, this is worthwhile doing. This last one. That was more of the last question I was doing just now, and 9 as well. You can do that. I don't know I can't remember if I selected that question or not. You can test yourself if you want. For each of the following, give coordinates of the Axis Intercept. So again, here you're trying to find X-Intercept, Y-Intercept. Let X go to 0 or let Y go to 0. Sketch the graphs of each of the following linear equations. So again, that was my first example. Sketch the graph of finding the Axis Intercepts. That's my second example. Determine the Axis Intercepts, and that's pretty much all the same. Okay, they're all the same techniques. So if you can work with a fraction, so if you notice this one, that looks harder, do that. Okay, it's all about challenging yourself. The example I always give to my students is, it's like gymming. Yeah, if you go in and you lift up 1 kilo weights and you do, you know, like 10, and you're like, yep, that's enough for today. It doesn't matter if you do 10. You're never going to get big. You're never going to get strong. Yeah, if you want to get better, don't do the things you can already do. Do things you can't do. So if you can already do 1 kilo weights, try 10. Do bicep curls on 10. You might struggle the first few, but as you keep trying, you get better, you get stronger. Yeah. Same thing with mathematics. If you already know how to do the questions, okay, if you did 1, 2, and 3 and it was very easy, don't do them. or do 1A, do 1D. You could do that, jump to 2F. If you can't do that, then do more of these questions. If you can do that, jump to 3C. You know, whatever I chose, pick the last ones, pick the hard ones. If you could do all that, jump, you know, for each one, just do 4D, 5E, 6, whatever number of questions I choose one of them until you get to a one where you can't do. Okay? Study efficiently, study smart. Don't study hard and laboriously. That's ineffective. Yeah? Study smart. So choose the ones that you can do. Choose the ones you can't do or find it difficult to do. Work on those. Like question 7, I can see a lot of students struggling with E, F, G, and definitely C. You know, students don't like fractions. Yeah? Sketch these ones. Most students forget these. You know, vertical lines. Any x equals finds a vertical line at 5. Y equals -2 is a horizontal line at -2. This is at 5. Okay. And then these ones, definitely 9 and 10. That's a year 11 thing to pick up. So a lot of you guys will find this tricky. So do practice them. Do all those questions. Do 9 and 10. Okay. But if you're still practicing your algebra, do these 1 to 8. Pick and choose. Yeah. Be smart with your choices. You don't have to do all. Yeah. All right. That concludes this second video for today. And how long did this take me? Let's go. Let's have a look. It took me